Yeah, good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening. Yeah, good evening, Pratish, Anugraha, Aniruddhan, and Roshni. Yeah, I've shared my screen. It's a blank screen. Is it visible?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah, today I'll text the reason later. I was just telling the students present in the class here today. So for some reason, I'm giving the introduction to the chapter volumes and surface areas in today's class. We'll resume polynomials from Saturday. All right. I'll write the formula. You tell me what it is. Okay. This is the formula to find volume of cylinder. This is the formula to find volume of cone. This is the formula to find volume of a sphere. And this one, hemisphere. Okay. This is the formula to find the TSA of a cylinder. TSA of a cylinder. TSA of a cone. Sphere. CSA of hemisphere. CSA of hemisphere. 2 pi r square is the formula to find the CSA, curved surface area of a hemisphere. Yeah, online students, please participate. 3 pi r square. TSA of a hemisphere. TSA of a hemisphere. Diagonal of a cuboid. Diagonal, the length of the diagonal of a cuboid. Is the formula correct? This is the formula to find the diagonal of a cuboid. Now, will this expression help you to find anything? Root 3a. Root 3a. Okay, 1 minute. When will we use this formula? No, not solid. This is a plane figure formula. Root of L squared plus B squared will help you find what? Of a plane figure, not a solid. What? Diagonal of a rectangle. Root of L squared plus B squared. Root of L squared plus B squared is the formula to find the diagonal of a rectangle. Length, breadth, Pythagoras theorem. Length, breadth. Length, breadth, and by Pythagoras theorem, this is root of L square plus B square, the diagonal of a rectangle. So root of L square plus B square plus H square is the length of the diagonal of a cuboid. Okay. Then for a square, what's the formula to find the diagonal of a square? This is A. This is A. So hypotenuse is equal to root. Diagonal is equal to, so here diagonal is equal to A square plus A square. Okay. Oh, sorry. Diagonal square. Diagonal square is equal to A square plus A square. Diagonal square is equal to 2A square. So diagonal is equal to root of 2A square. So that is 2A. Sorry, root 2A. Root 2A, right? I'll just take a. I'll just take the next slide. 1 second. I'm just squeezing. Square square, all sides equal, diagonal, right angle, right triangle. Okay, so diagonal of the square, d square is equal to a square plus a square by Pythagoras theorem. D square is equal to 2a square. D is equal to square root of 2a square. D is equal to root 2a units. So what is this? This is the formula to find the length of the diagonal of a square. Then what is root 3a? This is the formula to find the length of the diagonal of a cuboid. No, sorry, cube. Cube. Root 2a is for the plane figure square. Root 2a is for the plane figure square. Okay, the length of the diagonal of a square is given by the formula root 2a. Now, solid cube. All right. The length of the diagonal of a cube is given by the formula root 3a. Rectangle diagonal root of L square plus B square. Cuboid diagonal root of L square plus B square plus H square. All right. So root 3a is a formula to find the diagonal of a cube. Diagonal of a cube. Okay, so what is, okay, hectare is a unit of length, area, volume, what? Area. Hectare is a unit for area. Hectare is a unit for area. When you say 1 hectare is not length. Length is, when we say 1 hectare, it does not, it's not one dimensional. Hectare is not a unit used for one dimension. Like for length, you will say 1 centimeter, 10 centimeters or meters, centimeter, meter, hectometer, decimeter. These are units for length, one dimension, length. All right. Hectare is not a unit for length. You cannot measure the length of something and say 1 hectare. Hectare is a unit for area. Hectare is a unit for area. And what is the area of 1 hectare equal to? The area of 1 hectare is equal to 10,000 meters square. Area of 1 hectare is equal to 10,000 meters square. 10,000 meters square is equal to 1 hectare. An area of 10,000 meters square is equal to 1 hectare. Okay. Yeah, nothing much. I'll come back to the formula in case you've forgotten something. I'll get started with this. Look at this question. A solid wooden toy. A solid. So this year you will see combination of solids. Combination of solids. All right. Last year we learned about the volume surface area of solids like cylinder, cone, hemisphere, cuboid. Okay. So now this year you will be seeing, you will learn how to compute area and volume of a combination of solids. Composite solids, like you say, composite plane figures, no? A combination of a rectangle and a semicircle. A composite plane figure. A composite plane figure is a plane figure which is made up of 2 or more figures. See, suppose I put a triangle here. Find the area of the shape. Find the perimeter of the shape. It's a composite shape because it's made up of more than one plane figure. This one is a composite shape. It's a composite plane figure because it's made up of more than one plane figure. There's a rectangle, there's a semicircle, there's a triangle. So it's a composite plane figure. Similarly, with solids also we have composite solids, a combination of 2 or more solids, like the pencil. Like the pencil, when you get a new, we're talking about the regular wooden pencil, okay, not the mechanical one. So the pencil, it's now we have, you know, like some. I'm talking about the cylindrical pencil. All right. So when you sharpen it, it's a combination of a cylinder and a cone. It's a combination of a cylinder and a cone. Okay. So similarly, this have you Okay, yeah. Very traditional game. I think played all over India. I won't say South India, played all over India. So, okay, we have forgotten. We don't know. We don't go out of the house at all. We're not allowed to go out of the house now. So, we are raised with utmost protection and so, yeah. So, this is Gilli Danda. Gilli Danda. Danda means stick. Danda is a stick. And Gilli is, so have you seen how this is played? Yeah, so this gilli is a combination of a cylinder with conical ends. This gilli is a combination, it's a solid. Okay, this gilli is a solid made of wood. Okay, both the pieces are made of wood. Both the pieces are made of wood. Now this gilli is a combination of a cylinder and two cones. So it's cylindrical with conical ends. Okay, a gilli is a cylinder with conical ends. It's not rectangle and triangle. It's a solid. It's a solid. So a gilli is a cylinder, correct? It's a cylinder with conical ends. So imagine a cylinder with two cones stuck. Conical ends. Am I clear? This danda is a stick. It's a cylinder. Danda is a cylinder. It's a stick. It's a stick. So it's cylindrical, completely cylindrical. So this gilli danda, in this gilli danda, this gilli is a combination of a cylinder and, okay, combination of a cylinder and two cones. Okay, not a cone, two cones. A cylinder and two cones. Correct? Danda is just a cylinder. Okay. So we said what? First I said what? Yeah, a combination of cylinder and cone is one cone. Cylinder and one cone is a sharpened pencil. This one we understood. Now in your lab, okay, in your science lab, you have a different kinds of flask, right? Flasks. Okay, so let's take this flask. I think it's called a round bottomed flask, right? It's called a round bottomed flask. A round bottomed flask. So this is a combination of this one is mostly spherical with a cylindrical neck. It's spherical with a cylindrical neck. So if you have to, supposing this one is completely filled with whatever the solution, okay, completely filled with some safe solution. That's why it's filled till here. If it's filled with acid, probably only this much. Okay, some very safe solution, so it's filled till here. Okay. So this round bottomed flask, okay, is a combination of a sphere and a cylinder. Sphere and a cylinder. Spherical bottom with a conical, I'm so sorry, cylindrical neck. Cylindrical neck. We can see it here. Right? All right. All right, now let's come back to this question. So like this, we'll be dealing with combination of solids. We'll be dealing with combination of solids. We'll learn how to find volume, surface area of combination of solids. So in this question, a solid wooden toy is in the form of a hemisphere surmounted by a cone. Hemisphere, surmounted by a cone. That means on top of this, there's a cone like this. Let's understand first and then we'll start working. So this toy is in the form of a hemisphere. So you can see the bottom, it's a hemisphere surmounted by a cone. That means there's a cone on top of the hemisphere. And of course, the toy will not stand like this, no? The toy cannot stand with this one. So it's like this is the toy. So you can rock it, it will not fall at all. You rock it, it will not fall, it will just go left, right like that. Okay, so this is the toy. And the radius of the cone and the radius of the hemisphere is the same. Okay, the radius of the cone and the hemisphere is the same. Okay, the radius of the okay, now before I read the question, let me tell you something. Now, what are the two solids here? Hemisphere and cone. So to answer any question, you need what for the hemisphere? Just the radius. For hemisphere, if you know the radius, you can calculate anything. Because all the formulae for the hemisphere, you have to fill only r there. 2 by 3 pi r cubed, 2 pi r square, 3 pi r square. So if you know the value of r, you can answer anything about the hemisphere. Then cone. For cone, we have three parameters. We have radius, height, and slant height. So if you know any two, you can find the third one. But you need to know two of them. You need to have three of the two, height, radius, and slant height. So of these three, if you know any two, you can find the third one. Okay. Okay. So that's what you should look out for. What information you have. What information you have. So now for the hemisphere, you know the radius. Okay. And for the cone, you know the radius. Let's see what ahead. And the total wood used in making the toy is 166 5 by 6 centimeter cube. The total wood used in make. So the total wood meaning the volume of the wood. And you can also see the unit there, centimeter cube. When do you use this unit cube? Centimeter cube for volume. Okay, that the total wood used meaning the total volume of wood. It's not mentioned volume, but total wood meaning the total volume of wood used to make the toy is 166 5 by 6 centimeter cube. You can also make out from the unit. Even if this was printed centimeter square, it is volume only. This is a printing mistake. So don't go by this. I'm just telling you. Don't go by this unit. Total wood used means it is volume only. Okay. Okay. Now the question is find the height of the toy. Yeah, no, the volume is given. So you have to find the height of the toy. Height of the toy meaning you should find the height of the hemisphere, you know. Okay. The toy means what? Toy is the hemisphere and the cone together is the toy. Hemisphere is hemisphere, cone is cone. Hemispherical height, conical height. The hemispherical height plus the conical height is the height of the toy. How will you find the height of the toy? How will you find the height of the toy? Height of the toy is from here to here. So the height of the toy is made up of the conical height and the hemispherical height. Hemispherical height we already know because whatever is the radius is the height of the hemisphere. So 3.5 we already know the height of the hemisphere. Whatever is the radius of the hemisphere is the height of the hemisphere. So we know it. So we have to find to answer this question, we have to find the height of the cone. That's all. If you find the height of the cone plus height of hemisphere will give you the height of the toy. Okay, we'll read the second part of the question later. So you can start working with me. You can please write down the question. Now the confusion is, should I continue? That you decide. Should you continue with polynomials or what? So you decide that. now I want to have your attention. Please listen to me. Stop writing. Now read these three equations. Volume of wood used to make the toy is 166 5 by 6 centimeter cube. This is what is given. All right. So how do you express that? Volume of cone plus volume of hemisphere is equal to, I've converted that to an improper fraction. So what is volume of cone formula? 1 by 3 pi r square h. And this one hemisphere, hs is hemisphere, 2 by 3 pi r cube. Now see here, you can use r because the value of r is the same. Otherwise, you must use r1, r2. Supposing there are two solids with different radius, you should differentiate using r1, r2 or capital R, small r, whatever. But you should not use r in both the cases because they have different radius. Now they have the same radius, so we're using r only. And h, we don't have to say h1, h2 because for in the hemispheres formula, we don't have h. So this can remain h itself. What is h here? The height of the cone. Okay, so now take out common. What's common? 1 by 3 is common, pi is common, r square is common. So what do you get in the bracket? H plus, not 2 by 3. 2 into 1 by 3 is 2 by 3. 2 into 1 by 3 is 2 by 3. So 1 by 3 is outside. So into 2 is 2 by 3. Pi is outside. So r is equal to 1001 by 6. Is this understood? Now, 1 by 3 into pi, the value of pi is 22 by 7 into r, 3.5 into 3.5. Correct? 3.5 into 3.5. I'll just do it here. I'll do it here. 1 by 3 into 22 by 7 into 3.5 into 3.5 r square into h. We don't know. Plus 2r. 2r is 7. 2 into 3.5 is 7. Correct? Is equal to 1001 by 6. Now you should work and tell me the value of h. Yeah, continue. Work this equation and find the value of h. That's all. Draw the figure and then start working. Write the question, draw the figure. One second. All of you must get the correct value for H. Yeah. Yeah, what's the value of H? 5, huh? No, she said 5. 5? No, not the height of the tall. Value of H. 5, huh? 6. Okay.
Ma'am, H is equal to 6.
6, Pratish. Okay. So here we have 22 by 3 into 35 into 5. When you multiply, it's 1.75 into H plus 7 is equal to 1001 by 6. We'll transpose. So H plus 7 will transpose. So H plus 7 is equal to 1001 by 6 into 3 by 22 into 3 by 22. And this is 1.7. Let me write it as 175 by 100. 11, 11, 9s are 99, 1 remains, 11 ones are 11, 2 times. 7 ones are 13, 7s are 91, 2 ones are 2 twos are 3 ones are 3 twos are. So H is equal to 13 minus 7, H is equal to 6. Correct. Right, darling, you went wrong. 3 plus 2 pantingla, 3 into 2. So H is 6. What is H? The height of the cone. But the question is to find the height of the toy. So height of the toy is equal to the conical height 6 plus a cylindrical height, or not cylindrical height, hemispherical height 3.5. Correct? So 9.5. 9.5. Or you can write, you can express yourself here. Height of cone plus height of hemisphere. Height of toy is equal to height of cone plus height of hemisphere. Height of hemisphere. Cone is 6 plus hemisphere is 3.5. So 9.5 centimeters. Okay, I'll tell you how I calculated. So I simplified 7 and this 3.5, 0.5 times. Then this is what 22 by this 22 by 3 into I multiplied these two. I got 1.75 H plus 7 and this one. Now I tried to transpose, then this will go for division. No, divided by 1 will come in the denominator 1.75. So I came back. What I did, I wrote 1.75 as 175 by 100. I changed that to a fraction. I changed that to a fraction 175 by 100. So now it is divisible in the tables of 25. No, so 25 sevens are 25 fours are. Now these fractions we transpose. So H plus 7 remains here is equal to 1001 by 6. Transpose the two fractions. So 3 by 22 and 4 by 7 on the other side, and then simplify. Okay, you can 22 and 1001 in the tables of 11. 22 and 1001 in the tables of 11. So you simplify, you get 13, and 13 minus 7, H is 6. All right. Yeah, the next part of the question is also find the cost of painting the hemispherical part. Only hemispherical part, not the toy. That's where we'll go wrong. What we'll do, painting. Okay, immediately we'll find for the toy. That's how we lose marks. Not for toy. Find the cost of painting the hemispherical part of the toy at the rate of rupees 10 per centimeter square. So what should you do? What should you find? Area, no? Whenever it's painting, it's area. Whenever it's painting, it's area. Okay. So cost of painting, it's just a surface, the outer surface. Hemisphere, can you see the top part of the hemisphere? No, because the cone is stuck. Hemisphere, in the hemisphere, can you see that circular top? A hemisphere has a circular top, right? Can we see the circular top of the hemisphere? No, because the cone sits on the top of the hemisphere. So what or which portion of the hemisphere is visible to be painted or is available to be painted? Only the CSA. Hemisphere is like this. Yeah, correct. When it's hemisphere, you can paint the CSA and the circle on the top, correct. But the circle on the top is not, exposed to be painted. The cone is stuck. So what is exposed? Only the CSA of the hemisphere. So you should find 2 pi r square and multiply by 10 to get the cost of painting. Find 2 pi r square, only the CSA, because only that is exposed. Excuse me. All right. Next one. Finished? Still working? Yeah. Please complete. Yeah, children. Next one. Yeah, we'll do this one. A solid cylinder of diameter 12 centimeters and height 15 centimeters. So for the cylinder, we know both the parameters, diameter and height, radius and height, both known. Okay. So now this cylinder is melted and recast into 12 toys in the shape of a right circular cone mounted on a hemisphere. So a solid cylinder like this 12, like this 12. The solid cylinder is melted and recast into 12 toys. Each toy, 12 identical toys, 12 toys, 12 identical toys in the shape of a right circular cone mounted on the cone is on a hemisphere. So this one. Same thing like what we just saw. Hemisphere on a, cone on a hemisphere. Now find the radius of the hemisphere if the total height of the toy, find the radius of the hemisphere and the total height of the toy if the height of the cone is 3 times the radius. Okay, which is the, let me read the last part again. The height of the cone is 3 times the radius. height of the cone. This is the conical height. So this is 3r. What is the radius of the cone? R. What's the radius of the hemisphere? R. See, now we need to understand like this. For the cylinder, we know both radius and height. Both are known. Okay, good. Now for the toy, in the toy there is cone. For the cone, what's the radius? R. What's the height? 3r. Okay. And for the hemisphere, what's the radius? R. Okay, so there's only one. These two we know. So in all, there is only one unknown, R. All right. There's only one unknown R. Yes or no? What is the height of the solid cylinder? What is the height of the solid cylinder? 15 centimeters. What is the height? What is the radius of the solid cylinder? 6 centimeters. Now the cylinder is made into 12 toys, and by each toy has a hemisphere and a cone. What is the radius of the hemisphere? R. Radius of the hemisphere is not given. R. What's the height of the hemisphere? R. What's the radius of the, again, what is the radius of the hemisphere? What is the height of the hemisphere? What is the radius of the cone? R. What is the height of the cone? 3r. Online children? For hemisphere, what is the radius of the hemisphere? Radius of hemisphere? R. Height of hemisphere? R.
R.
Height of, yeah, R. Height of hemisphere is also R. Radius of the cone? R. Height of the cone?
3R.
3r. 3r. Okay. So now with this information, we have to find the radius of the hemisphere and the total height of the toy. Radius of the hemisphere and the total height of the toy. All right. See, you should always create that equation in words. There's nothing easier than this chapter. You should just create that equation word. See here, in this question, what is the equation? Volume of wood used to make the toy is equal to this one. That's it. If you write that, the rest of the steps just follow. Because what is the toy made up of? Cone and hemisphere. So you'll write that in the next step. In the next step, you'll write the formula. And the next step, you'll take out common. Next step, you'll substitute the values given. And then you get one equation in unknown h. And you'll solve the equation for h. The first equation is important. How you decode the question, that first equation is important. You write this one correctly. And that too in words you have to write, not using formula. Just write that first equation in words. And for that, we need to understand the question clearly. Read the question, comprehend the question, and write that first equation in words correctly. If you do that, then everything is simple. See now, what is the equation words? So volume of 12 toys is equal to volume of solid cylinder. Is this correct? That's all. When you read the question, what is it you understand? In words you write, not using mathematical formula, just using words. So when you read the question, so what is it about? Like in English, you're asked to read a passage and give a title, give a suitable title to the passage. Right? Yeah. So like that, read the question and write an appropriate equation using words. So you can write this way also. You can write volume of solid cylinder is equal to volume of 12 toys. Anyways, you can write it. So I have written volume of 12 toys is equal to volume of solid cylinder. Normally, you want to have that number in the RHS, right? Number. So here, since for the solid cylinder, we know the radius and height. So we have a number in the R. So I put it like this. You can write it the other way also. See, volume of solid cylinder, what's the formula? Pi r square h. You know R, you know h also. So the RHS will become a number, no? So நம்மளோட unknown வந்து LHSல தான் இருக்கும். இப்படிதான் எழுதணும்னு இல்லை, எப்படி வேணாலும் எழுதலாம். But I have written like this because the RHS will now become a after substituting will become a number. So if you write this, see what will you write in the next step? Tell me. How will you, what is volume of 12 toys? 12 into volume of 1 toy, correct? Volume of 12 toys is 12 into volume of 1 toy is equal to volume. We'll write the formula like throughout, okay? We'll not substitute the formula now. We'll just write this. So let's say, okay. Now 12 into, what's the volume of 1 toy? How will you break this? Tell me. How will you break this? How will you break volume of 1 toy? Correct. Correct. How will you further break down this volume of 1 toy, online students? The toy is like this. So it is volume of hemisphere plus volume of cone. This is for 1 toy. Into 12 is 12 toys. Is equal to volume of solid cylinder. Now 12 into formula to find the volume of a hemisphere. 2 by 3 pi r cube. Very good. Plus cone. Is equal to formula. Now, இப்படியா? No, I cannot use the same letter, no, R, because capital, yeah, we'll use a capital R and capital H. We'll use a capital R and capital H, pi R square H, like this. Because this R value is different from this R value. These two R's have the same value. This R has a different value. And the height also, this height is different, this height is different. So we'll use capital R and capital H here. Just to differentiate, even if you write pi small r square and small h, then you will substitute the correct values. You will not go wrong with your answer. But if you want to be like perfect everywhere, yeah, I think you can do this. All right. Okay. Next, what? Tell me. Common. See, common. So 12 into what's common? 1 by 3 into pi r square. Then in bracket, R 2 by 3 pi, plus H is equal to 1 minute. Let me just write this. So 12 into 1 by 3 pi r square, no? Yeah. 12 into 1 by 3 pi r square is common. 2r plus h is equal to pi r square h. All right. Now this pi and pi on both the sides will get cancelled. Pi on either side gets cancelled. Then 3 1s are 3 4s are. Correct? Then what is left here? 4r square. 4r square into 2r. And read the question for h. What is given? Height of the cone is 3 times the radius. 3r. Height of the cone, not height of the toy, height of the cone only. Height of the cone is 3 times the radius. So h is 3r. Is equal to, now substitute the values. What is r square? 6 into 6 into 15. That's all. Solve and find the value of r. Good. Please write down the question and then work the answer.
Ma'am, R is equal to 3.
R is equal to 3. Roshni, is it?
Yes, ma'am.
Okay. 4R square. Roshni, did you write the question? Or you just work the answer?
Ma'am, I wrote the question and I worked.
Very good, very good. Okay. Okay, I'll just wait and just give others some time to complete. We'll see. You said RS, come again, RS?
R is equal to 3.
3, okay. What 3? Okay. You need not multiply 6 into 6 into 15. Don't multiply. Then some numbers will come for division. Simplify. No question. Yeah, what is that you're researching in the question? No, just a second. Why are you writing the question this long? It's not clear or something? You started working the answer or writing the question? Okay, it's time. Have we got 3? Swati's got? Who else? Got 3?
Ma'am, R is 3.
R is 3. Who's this? Let's okay. That's what most of your friends have got. Let's see. 3. Okay. So 2R plus 3R is 5R. 5R. Okay. Into 5R is equal to, see, I'm not multiplying. You want to connect 36 into 15. Okay, fine. So R square into R is R cubed. R square into R is R cubed is equal to 6 into 6 into 15 over 4 into 5. Correct? So 5 ones are 5 threes are. 4, no, 2 twos are 2 threes are. Again, 2 ones are 2 threes are. So we have what? See, R cubed is equal to 3 into 3 into 3. So R is 3. R is equal to cube root of 3 into 3 into 3. You don't have to multiply at all. R is equal to cube root of 3 into 3 into 3. So R is equal to 3. So we need to find the radius of the hemisphere, 3. And the height of the toy. What's the height of the toy? Correct. Very good. 3R plus R. Height of the toy is 3R plus R. What's the height of the cone? 3R. What's the height of the cylinder? R. So what's the height of the toy? 3R plus R, 4R. 4 into 3, 12 centimeters. Very good. Height of toy is equal to 3R plus R. You please write that. Height of cone plus height of hemisphere. Height of toy is equal to height of cone plus height of hemisphere. என்ன இருக்கீங்க சிரிக்கிறதுக்கு? Height of hemisphere plus height of cone. So R plus 3R, 4R, which is 4 into 3, 12 centimeters. Any questions, online students?
No, ma'am.
Okay. Yeah. See, we have done all this with plane figures in class 6, 7, 8. This is using solids. A solid is composed of a cylinder with hemispherical ends. Cylinder with hemispherical ends. Radius, hemispherical ends. A solid is composed of a cylinder with hemispherical ends. If the whole length of the solid is 104 centimeters, and the radius of each of its hemispherical ends, radius of each hemispherical end is 7 centimeters. Find the cost of polishing its surface at the rate of ₹10 per decimeter square. Don't worry about that. Don't worry about decimeter square. We'll find the area in centimeter square. We'll convert that to decimeter square. You don't convert every unit to decimeter. You don't convert centimeter everywhere to decimeter. You find the area in centimeter square. That area, once for all, you can convert it to decimeter square and then multiply it with the rate. Okay, so a solid, so it's a this solid is a cylinder with hemispherical ends, and the whole length of the toy is 104 centimeters. So what's the whole length made up of? It's the height of the hemisphere, or you can say the length here because it's horizontal. What should I say? Okay, I'll say height only. So it's the height of the hemisphere plus the length of the cylinder plus the height of the hemisphere. The length of what is 104 made up of? What is 104 made up of? 104 is made up of the height of the hemisphere, the length or the height of the cylinder, and the height or length of the hemisphere. Three things add to 104. Three things add to 104, correct? Okay. So the whole length is 104 and the radius of each hemispherical end is 7. So that means this is 7, this is 7. So 7 plus h plus 7 is equal to 104, correct? So you can find h from this. It's 90. That is the height of the cylinder is 90. 104 minus 14, which is 90. So what will be the, how will you find the area to be polished? It is the CSA of the cylinder plus the CSA of the two hemispheres. Only CSA. So whatever is visible, whatever is available, whatever area is available to be painted, what area of the cylinder is available to be painted? Only the CSA. Because the circles of the cylinder you cannot see. The circular ends of the cylinder, they're not visible, no? Because the hemispheres are stuck there. So you can paint only the CSA of the cylinder and also hemispherical end. So you can only paint the CSA of the hemisphere. All right. We'll do it together. Start working. Now you will convert centimeter square to decimeter square and find the cost. That's your work. Do it and tell me.
Ma'am, 45.757 decimeter square.
45.7.
757 decimeter square. Ma'am.
How 757? I have only these digits 454, 4576, no? 45 point. No. No, you're one of the digits. Come again. Let me write. Pritesh. Yeah, Pritesh. Yeah. 45 point.
Ma'am, 757.
757 இதெல்லாம் எங்கன்னு புதுசா இருக்க டிஜிட்ஸ் இதெல்லாம் இங்க இல்லவே இல்லையே. ஏரியா வந்து 4576 is my multiplication correct? Okay, Pratish, have you got this value for area?
I got it wrong.
Oh, you got a different answer. Huh? Oh, no, you can't say you're wrong. I don't know. Please check. Yeah. Yeah, you please check your calculation. Here, you please check mine. No, work and see. You got the same thing? Yeah, how do we convert centimeter square to decimeter square? Which is bigger of the two, centimeter or decimeter? Which is the bigger unit? Millimeter, centimeter, decimeter, meter. Millimeter, centimeter, then decimeter, then meter. Decimeter is a larger unit when compared to centimeter. So how will you convert centimeter to decimeter? Will you multiply by 10 or divide by 10? Divide by 10. So centimeter square to decimeter square, divide by 100. Okay, so see, it's like this. For conversion, millimeter, centimeter, decimeter, meter. So you're coming down, so you should divide. And the number is 10. The number is 10. Okay, so you should divide by, to convert centimeter to decimeter, should divide by 10. To convert centimeter square to decimeter square, do that action 2 times. Do this 2 times. So it will be 10 and 10 again, 100. Divide by 100. Divide by 100. One extra zero you should put, that's all. If it is centimeter cube to meter, decimeter cube, you should divide by so it will be 4576 divided by 100 decimeter square. This one is centimeter square. When you divide by 100, it's converted to decimeter square. So that is 45.76 decimeter square. Now the cost of polishing. Cost of polishing is equal to 45.76 into 10, no? 10. 57.6. All right, very good. Just take to the previous slide. Have you all finished? This one, all of you finished? Okay. All right. Next one. We'll do this one. Oh, 1 minute. Oh, trigonometry, you know. Hold it. A vessel full of water, okay, is in the form of an inverted cone. A vessel full of water is in the form of an inverted cone. Why inverted cone? Is because cone is like this. This is how you draw a cone. Meaning cone, it should sit on its circular base, right? So this is a cone. Inverted cone is when you have your ice cream. It's an inverted cone. When the cone is a container, it's an inverted cone. When you put that conical cap, it's a cone. It's a conical cap. But when you're having an ice cream cone is an inverted cone. When you're using it as a vessel or a container, then it becomes an inverted cone. So an inverted cone, a vessel, 1 second. A vessel full of water is in the form of an inverted cone of height and radius given to you, okay? 5 centimeters, height 8 and radius 5. 100 spherical lead balls, lead is the material. Spherical is the solid. So 100 spherical lead balls are dropped into the vessel. 1/4 of the water flows out of the vessel. Find the radius of the spherical ball. So everywhere it's only about reading the question and writing that first equation in words. Believe me, if you write it, as I told you earlier, you'll smoothly, work through the answer. Now you should tell me that equation in words. You should tell me, read the question and tell me that equation in words. Online children, read the question and tell me the equation in words. I forgot. What's the equation in words? Yeah. So this is very much like your, you might have had that, no? Reading a passage and giving a suitable title. Quite சின்ன வயசுல, maybe not now, but yeah, but அப்ப வந்து என்ன டைட்டில் வேணாலும் கொடுக்கலாம். இப்போ இதுக்கு ஒரு word equation தான் எழுத முடியும். So the equation is, let's see if you can complete it. So you should find the, okay. So volume of the 100 spherical Let me write. Okay. Spherical balls is equal to. Complete it. Correct. Is equal to the volume of water that flows out of the vessel. That's all. You thought the same. You didn't share it with me. You wrote. Okay. So volume of the, that's what you can say from this. Volume of the 100 spherical balls is equal to volume of the water that flows out. What volume of water will flow out? It will be equal. See, something is, like taking space inside the container. Equivalent to that, something flows out. What are you dropping inside the container? The 100 spherical balls. So what will flow out? The volume equivalent to that will flow out. So volume of the 100 spherical balls is equal to volume of the water that flows out. Will be exactly equal to the volume of the water that flows out. Somebody is entering, equivalent will exit. Somebody is entering, no? So equivalent will exit. So what is exiting? Water. What's entering? The spherical balls. So the volume of the 100 spherical balls is equal to volume of water that overflows. That overflows or flows out or whatever. That overflows. This is the equation. That's all. Now see. So it will be 100 into what is volume of one spherical ball? Okay, volume of one spherical ball is equal to what is the volume of water that flows out? 1/4. It's given 1/4 of the volume of the water flows out. 1/4 of the volume of cone. Correct? 1/4 of the water flows out of the vessel. So 1/4 of the volume of the cone. 1/4. On the cone level, the 1/4 வெளியில வந்திருது. That means 1/4 of the volume of the cone only, no? What is the volume of the water in the cone? It is equal to the volume of the cone. Because the cone is full of water, volume of the cone, volume of the water, both are the same. Okay, so volume of one spherical ball, 4/3 pi r cubed is equal to 1/4 into 1/3 pi r. We should use a different r, no? You can say R1 or capital R, whatever. Okay, 1/3 pi r square h. Angada h illiye. So you can use a small h itself. You can use a capital H also. Nothing wrong about that. If you feel I've taken a capital R, so I want to use a capital H, yeah, you can use. You can use a capital H. Now what gets cancelled on both sides? The 3 and 3, no? The 3 and 3 on both sides gets cancelled. Yeah, pi and pi gets cancelled. See? That's what you should do first. 22/7 la podakudadu. Pi gets cancelled on both the sides. 3 gets cancelled on both the sides. So what is remaining now? 100 into 4 venna 400 போட்டுக்கலாம். இல்லனா 100 into 4 ne போடலாம். 100 into 4 into r cube. இதுதான் கண்டுபிடிக்கணும். Radius of the spherical ball தான் கண்டுபிடிக்கணும். So that's not known. R cube is equal to 1/4 into r square such 5. 5 into 5 into 8. See, that's all. So r cube is equal to 5 into 5. Let me write like divided by 100 into 4 into 4. Correct? This is correct? Yeah, now cancel. 5/25. So this is 4. Then I'll just cancel like this. Okay, 8 ones are, this is 4 4 the 16, 16 4 the 64, right? So let me write 1/8. You cancel, you'll get 1/8. Okay, 1/8. So 1 r cubed is equal to 1/8 or 1/2 the whole cubed. So r is equal to 1/2 or r is equal to 0.5 centimeters. 0.5 centimeters. 1/2 centimeter or 0.5 centimeter. Yeah. Please work. Any questions, children? Online children? Okay. Why I'm not hearing from Aniruddhan today? Are you there? Children, raise your hand. Online children, raise your hand. Use emoji. That's Roshni, Pratish, Anugraha, Jayavarshini, Gamayan, Aniruddhan. Okay, very good, children. Yeah, let's continue. Oh, these are different type of questions, so I'm just trying to do similar ones today. Okay, we might do this. Very different, but we can do this. A right triangle whose legs are 15 and 20 centimeters is made to revolve about its hypotenuse. So you have studied in standard 9 that when you turn a right triangle about one of its legs. See, okay, a triangle has 3 sides. A triangle has 3 sides. So in the case of a right triangle, the sides are called legs and hypotenuse. 2 legs and 1 hypotenuse. So in class 9, you have learned that when a right triangle is turned about one of its legs, when you turn a right triangle about one of its legs, the solid generated is a cone. The solid generated is a cone. Okay, but when you turn a right triangle about its hypotenuse, the solid generated is a double cone. Okay. So here we have a right triangle. Okay. So in class, so this is one leg, this is the other leg, this is the hypotenuse. Now when you turn this right triangle about this leg, you turn it, okay? You turn it about this leg. When you turn it, so one complete turn. So you start like this and you turn and you come back to the starting point. You come back to the starting point. Okay. So when you turn a right triangle about one of its legs, that is, you keep this one as the axis. This leg is like fixed and this is fixed. So this one does not move, it's like fixed. So this one turns like this and comes back to the starting point. All right. Now this triangle would have traced the shape of a right circular cone. The triangle cannot become a cone because neither are you nor am I a magician. So this triangle cannot become a cone now. Okay, so the triangle is a triangle, but when it is rotated, it traces the shape of a right circular cone. Can you imagine that? You can just Google it. So many videos are there. They'll tell you more beautifully. Now you have to imagine. In my class, you have to imagine. Okay, or I have to insert that video on the PPT. Can you do that? Same thing with this side. See, like if you keep the triangle like this about this leg, so these legs have different measures. So if you turn it about this leg, also the solid traces a right circular cone. But when you turn it about its hypotenuse, this is the hypotenuse. When you turn it about the hypotenuse, a cone here and a cone here will be generated. So when a right triangle is turned or is rotated about its hypotenuse, the solid generated is a double cone, double cone. This is the right triangle. Yeah, so this is the right triangle. This is the hypotenuse. So we are turning it, meaning we are here. No, you should go one round and come back to the starting point. So you go like this, and you come back to the starting point like this. Yeah. So when you do that, there's a cone traced on this side and another cone traced on this side. They'll have the same radius. They'll have the same radius, but different heights. The two cones will have the same radius. They are two cones stuck to one another. The solid generated will be a double cone. The cones are stuck to one another. So they'll have the same radius, but they'll have different heights. The cone here might have a lesser height than the cone here. Heights like this here and here. Yes or no? Hypotenuse, like if the hypotenuse is 25, like maybe 10 is for one cone, 15 is for the other cone. 10 will go for one cone, the remaining 15 will go for the other cone, like that. So this is the hypotenuse. We turn the triangle about its hypotenuse. So when the right triangle is turned about its hypotenuse, the solid generated is a double cone. One cone on this side, one cone on this side. The two cones are stuck to one another, so they have the same radius, but they'll have different heights. The height will be like, this is the hypotenuse. A part of the hypotenuse becomes the height of one cone. The remaining part of the hypotenuse becomes the height of the other cone. Like I told you, this is 25, so 10 for one cone and 15 for the other cone. Radius will be the same for both. Radius will be the same for both. But if you turn it about its legs, the solid generated is only a cone. One single cone will be formed. So about the legs, only one cone. About the hypotenuse, double cone. Okay, two cones stuck to one another. Yeah, but that send the videos. Otherwise, you can just running a double cone totally. You'll see videos. You can understand. Okay, so here the question is, a right triangle whose legs are 15 and 20 centimeters is made to revolve about its hypotenuse. Find the volume and the surface area of the double cone formed. So the volume of the double cone will be volume of the small cone plus the volume of the big cone. Volume of the double cone will be volume of the small cone plus the volume of the big cone will be the volume of the double cone. Surface area of the double cone will be CSA of the small cone plus the CSA of the big cone. Why? Because CSA only is visible. The circles are not visible. The circular faces of the cone, they're stuck to one another. That's not visible. In the double cone, so this is the right triangle. This is the right angle of this. The top portion is a triangle. The top portion is a triangle. This is the triangle which you turn. Not two triangles, okay? Only one triangle. This is the triangle. When you turn it, like, see, you can see a cone on this side and you can see a cone on this side. The top portion is a triangle. Say triangle ABC. So we have this triangle, right triangle ABC, right angle at A, and you turn it about the hypotenuse BC. So can you see the cone ACA dash on the right side, and you can see the cone ABA dash on the left side. Okay, so and you can also see that the two cones, the circles of the circular faces of the two cones, they are stuck, so they'll have the same radius. This is the height of one cone. This is the height of the other cone. This one is the height of one cone. This is the height of the other cone. Till here. Correct? So to find the volume and surface area, To find volume, what you need? The radius and height. Radius and height. And for surface area, you also need the slant height. But you can see here that we don't have to find all that. You just need to find the radius. If you find the radius, you should remember all this. If you find the radius, that's enough. You can answer both the questions. We'll see how. We'll see how. See here. Okay. All right. So what is BC by Pythagoras theorem? BC by Pythagoras theorem. BC square is equal to AB square plus AC square. So BC square is equal to 15 square plus 20 square. So BC square is equal to 225 plus 400, 625. So BC is equal to 25 centimeter. So this is all we can find with the information given. So we found that. Now, AO is the radius of the two cones, right? AO or, okay, OA or OA dash, right? OA or OA dash is the radius of the two cones, correct? Okay. Now what we're going to do is we are going to find the area of the triangle ABC. Okay, in two different ways. We'll find the area of triangle ABC in two different ways. All right, because AO happens to be the height of the right triangle ABC. Let me not talk and work. A, B, C, AC is okay. I'll take this as 20 because this looks longer in my figure. I'll take this as 15 and this one is 25. The whole thing is 25. This is the right angle. This whole thing is 25. Correct? Okay. Now area of triangle ABC is equal to half into base into height or half product of legs. Half product of legs. This is the formula. So half into product of legs in a right triangle. So 20 into 15. So it's 150 centimeters square. Now, the same area can also be computed using half into the base BC into the altitude AO is also 150. Half into base BC into altitude AO is equal to 150. So half into 25 into AO is equal to 150. So AO is equal to 150 into, this is 25 by 2, it will become 2 by 25. So AO is equal to 25, 1, 6, so 12 centimeter. This is enough. The radius is enough. You don't have to find anything else. We'll see. Once I work it, you'll believe it better or you'll understand it better. Okay. Now let's answer the question. Volume of double cone is equal to 1 by 3 pi. What is R square? AO square, correct? Or OA square? AO, OA, whatever, AO square into H. What is H? OC. OC plus 1 by 3 pi. Same radius, no, AO only. 1 by 3 pi R square. What is R square? AO square into H. What is H? What's H? OB. OB. Volume of the double cone is equal to volume of the small cone plus the volume of the big cone. Okay, so it is 1/3 pi AO square, that is R square. Okay, AO square into H OC plus 1/3 pi R square AO square into H, which is OB. Okay. So 1/3 pi AO square is common. So in the bracket you will get OC plus OB. 1/3 pi AO square is common. So you get OC plus OB. So 1/3 into any pi value is given, yeah, 3.14 into 3.14 into what we find AO 12, no? Into we don't know OC OB, but we know OC plus OB. What is OC plus OB? BC. BC. So we don't have to spend time finding them. We can find when we learn similar. We can find now also using Pythagoras theorem. Oh, 12 square, no? So 1/3 pi 12 into 12 into this one is nothing but BC. So 25. So the thing is, you can find using Pythagoras theorem, you can find the value of, you will also learn, when you learn similar triangles, you can find using similar triangles, you can find the heights of the two cones separately, but you don't need to find because anyways, you're going to get OC plus OB, which is BC, which you already know, right? BC is 25. So why find the height separately? So this you will calculate and find the volume. Now the surface area. Okay, surface area of the double cone. Surface area of double cone. Surface area of double cone is equal to pi RL, right? Because it's only CSA. So pi RL, pi into AO into L. It was L for the small cone. AC, slant height. Slant height of the small cone, AC. Pi RL, AC. Plus pi into R, AO into L, AB. So again, what's common? Pi into AO is common. So AC plus AB. So pi is 3.14 into AO is 12 into AC. These are different values, hypotenuse, no? So AC is how much? 15. You can see here 15. And this is 20. 15. You can see 15 and 20. 15 and 20 are the slant heights of the two cones. Okay, 15 and 20. AC is 15. That's all. So this is 3.14 into 12 into 35. So you find that centimeter square. This is centimeter. Yeah. Is what?
Ma'am, can you show the next page, ma'am?
Yeah, sure. Done this one? Yeah, 2 minutes. What's the volume? Correct. Correct. 3768. Yeah, the second one. 1318.8. Correct. 1318.8. Correct. 1318.8. All right. Don't have time for another one. I'll just ask you one question. Now, supposing there's a cylinder. Okay, there's a cylinder, a solid cylinder. We have a solid cylinder, and from one end of the cylinder, we remove a cone. A conical cavity is made from one face of the cylinder. The solid cylinder, say made of wood. What you do is you drill out a conical cavity. You make a conical cavity. The radius of the conical cavity is equal to the radius of the cylinder. The height of the conical cavity is equal to the height of the cylinder. Okay. Now, what is the TSA of the remaining solid? What's the formula? I want that expression. Got the situation? Solid cylinder, from one end, we drill out a conical cavity. We make a conical cavity from one end. The radius and the height of the conical cavity is equal to the radius and the height of the cylinder. The question is, frame the expression to find the surface area of the remaining solid. Surface area of the remaining block. I want the expression. No. No. We are not talking about this one. Yeah. Now you just imagine you have a box of paint and a brush, and you have to paint this, solid all over. Where all will you paint? All the, you should write the formula to find the area of all those surfaces. That's all it is. To find the surface area, imagine that you have to paint. Now this is a solid, this is made of wood, right? So you want to paint it red. So where all you will be painting, all the surfaces where you will paint, write the formula to find the area of that surface and add everything. That will be the surface area of the remaining solid. Now, for example, say you start with painting the base. What's the area of the base? Pi r square. You will paint that. Okay. Next, where will you paint? Say you paint the CSA. You paint the CSA. So what's the area of that one? CSA area. 2 pi RH. 2 pi RH. Then you will see the top. When you see the top, oh, there is no circle on the top, because when conical cavity means you've removed the cone, right? Conical cavity is made. Cavity means now you have removed the cone. You've removed the cone. So when you remove the cone, what happens? That circular, the top circle of the cylinder goes away with the cone. So now you have painted the base of the cylinder, pi r square. You have painted the CSA of the cylinder, 2 pi r h. Now, where else you have, you have to paint? The inside, when you look inside, you can see that conical cavity. You'll have to paint that. So these are the 3 different surfaces available to be painted, right? You can look at the whole thing as 3 different surfaces. You'll paint the base. Okay, then you'll paint the CSA. Then you look inside, you see the conical cavity. You'll have to paint that. So what's the area of the conical cavity? Pi RL. Now tell me, is there any area which is left unpainted? Imagine. Base, okay. This one you painted, and inside, that's it, we're done, no? This is the formula to find the area of the remaining solid. The surface area of the remaining solid. Surface area is never calculated like surface area of the cylinder minus surface area of the cone. It's not like that. That's how we compute volume of the remaining solid. How do you compute the volume of the remaining solid? Volume of the remaining solid is volume of the cylinder minus the volume of the cone. What was there originally? Cylinder. What is removed? Cone. So the volume of the cylinder minus the volume of the cone is the volume of the remaining solid. That's how we compute volume. Volume remaining is original volume minus the volume removed. Volume works like that, but surface area never works like that. To find surface area, you should think of the surfaces. Just imagine you have to paint the remaining solid. So just think of the surfaces which you have to paint. So you start from wherever. You can even start from the inner cavity. The order is not important. So you can even start from the inner cavity. So you'll have to paint the inner cavity. So pi RL you'll paint. Then outside you have to paint the CSA of the cylinder. Okay. Then you have to paint the bottom of the cylinder. Okay. Now this wooden thing is completely red, or whatever your paint color is. It's completely yellow or completely blue. Right? Here on the top, there is no circle. It's gone with the cone. This is the surface area of the remaining solid. See, now actually the area is increased. By removing, the area is increased because this 2 pi RH and pi R square, and here this one, when you compute the area, it will be more than the area of pi R square. It will be more because it's pi RL, no? And the value of L is always more than the value of R. See, this is 2 pi RH plus pi R square, and this is pi R, supposing pi R square. What is pi R square? R into R, but this is R into L, and you know that the value of L is more than the value of R. So pi RL will have a greater value. So the area is increased now. When you remove the cone, area is increased. Okay, yeah. But volume will be, the volume of the remaining solid is volume of the cylinder pi R square H minus the volume of the cone 1 by 3 pi R square H. This is the volume of the remaining solid. Okay, so we'll see questions like this in the next. Oh, no, we'll continue with polynomials in the next class. Or maybe because we have started the last half an hour or last 20 minutes, we'll do 1 or 2 questions from volumes and surface areas just to continue. Maybe we'll do that. All right. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.